Okay, we are still in section 4.1. This is part 3 of that lecture. Now we're going to talk about how to, given a linear function f and the initial value and rate of change, evaluate f of c. So the first thing you need to do is determine the initial value and the rate of change. Now, they may not give these to you initially, but they may give you items that will allow you to find them, such as they may give you 2 points, and you would use those 2 points to find the slope. Next, we substitute them in and write the equation in slope-intercept form, or the function in slope-intercept form, and then we evaluate it at x equals c. And that's where we plug that in for x. So looking at this example, a farmer finds there is a linear relationship between the number of beanstalks N she plants and the yield Y each plant produces. When she plants 30 stalks, each plant yields 30 ounces of beans. When she plants 34 stalks, each plant produces 28 ounces of beans. Find a linear relationship in the form of Y equals MN plus B that gives the yield when N stalks are planted. So they don't give us M or B here. So it's up to us to find those items. So they do give us 2 points though. They give us the point when she plants 30 stalks, it yields 30 ounces of beans. And just to remind you, the number of beanstalks, that's N, and the yield each plant produces, that's your Y. Okay, so here is your first X and first Y from the first point, and then the second point is 34 stalks for 28 ounces of beans. So there's your second point. So I'm going to write these out. The first point is 30, 30. And the second point is 34, 28. And we will label these point 1 and point 2, which makes this x1 and y1. And this is x2 and y2. So we will first start by finding the slope. And just to remind you, the formula is y2 minus y1 over x2 minus x1. And y2 is 28 minus y1 is 30. X2 is 34 minus x1 is 30. So we get negative 2 over 4, which is negative 1/2. Now once we do that, we are going to, I gave you the choice in the last video. You can substitute this into y equals mx plus b, or into point slope form, y minus y1 equals m times x minus x1. Either way works. And just to remind you, since this is a new video, I'll show you in both. So I'm just going to pick a point. I'm going to use this one right there. So y is 30 equals m, which is negative 1/2. X is 30 plus b. So we have 30 equals negative 1/2 times 30 is negative 15 plus b. So we add 15 to both sides, and b equals 45. So now we have enough info to write the equation. Y equals negative 1/2 is your m, x plus 45. And let me just remind you that you can do it this other way. And I actually like this other way just because you sub things in once and then you're done. So if I were to sub in for y1 30 equals m, which is negative 1/2, times x minus x1, which is 30 as well. And then I would distribute your negative 1/2 to each term here, and we get negative 1/2 x plus 15, and then you would add 30 to both sides because your goal is to get your y by itself in the end, and you end up with the same thing that we ended up with over here. You end up with y equals negative 1/2 x plus 45. So either way, you get the same answer, and it's all about your preference. And as I said, I really prefer this method because I don't have to worry about, once I get to my B, having to worry about where to put it. But again, either way works, and I think they both take about the same amount of time. So whichever preference that you want to do, I'm okay with that. Now, I would most likely rewrite this in function notation. So f of n equals negative 1/2 x plus 45, because ultimately they asked for when it yielded in stalk. So if I were to, oh, and sorry, that shouldn't say x, should it? Let's erase that x. That x should actually say n, so 1/2 n plus 45. Negative 1/2 n plus 45 is the function. Now, if they told you to evaluate it at a certain n, so let's say n was evaluated at n equals 3, then you would put 3 in right there for n and solve it. Okay, so you guys try it. Try this one. They give you a table of values. They explain the scenario here. So again, you're going to write a linear function h of x based off of these points. Really, all you need is 2 points. And so just pause the video. When you unpause it, we'll go over the answer. Okay, so hopefully you worked through this problem. It says a new plant food was introduced to a young tree to test its effect on the height of the tree. Table shows the height of the tree in feet, x months, so 0 months, 2 months, 4 months, 8 months, and 12 months, since the measurements began. Write a linear function h of x, where x is the number of months since the start of the experiment. And then h would be the height of the tree in feet. So what you need to do here is first, you need to find the slope. So remember, our slope is y2 minus y1 over x2 minus x1. But you need to pick 2 points. If they ever have a 0, I like that one because 0 is easy to deal with. So I'm just going to pick those 2. But you could have picked this one and this one, or you could have picked this one and this one, or you could have picked this one and this one. It's up to you which 2 you pick. As long as it's linear, you're going to get the same slope no matter what. But I picked those 2. Okay, so this is my x1 and my y1, and this is my x2 and my y2. So plugging that into the formula, 13.5 minus 2, minus 12.5 on the top. On the bottom, I have 2 minus 0. And I get 13 minus 5 minus 12.5 is 1. 2 minus 0 is 2. So I get a slope of 1/2. Okay, so now let me just alert you to something. This lovely little point, that, you guys, is the y-intercept. This is your, that's your B. Because B is the y-intercept, which is where the x is 0. So in this particular problem, you do not have to go and substitute everything in like we did this one to solve for B. The reason? Because B, we already know, is 12.5. All you have to do is substitute your m, x plus b. B is 12.5. And so that's really all you have to do. Let's make sure I call the function the right thing. So h of x, the height is 1/2 x plus 12.5. And then we all know how to evaluate the function. So if I said evaluate the height function when the number of months is 9, you would substitute 9 here and you would solve. All right, so now we're going to graph. So this slide talks about graphing by plotting points. So basically, normally I would say make a table of values, but really to graph a line you need only 2 points. So for these steps it says choose a minimum of 2 input values. Does that mean that you only need to choose 2? It means that's the minimum. So if you choose 2, you should be okay, but you can choose more if you want. I usually do 5 myself, just because I want to make sure that I have the right line. Once you choose a minimum of 2 input values, next you're going to evaluate the function at each of those values, and then you'll get the resulting outputs, and then you will plot those coordinate pairs on the grid. So what I do is I just make a table of values, and I'm making this a little bit bigger because this is where I want to do the arithmetic in the center. So I'm going to plug in, it said you only need 2 points, okay, but you guys, I'm going to plug in a couple points to the, let's see, there's 1, 2, 3, 4, 5, 6, 7, let's just do 3. Let's do 3. I'm going to put in -4, 0, and 4. And you might think, why did she choose 4 and -4? Well, I'm kind of looking ahead, and I know I'm going to have to multiply times -1/4. And I know if I multiply it times -4/4, that it'll come out to be a nice whole number. Now, you're not limited to that. You could have substituted in 1 or 2 or 3. Again, you are choosing your input values. You need to choose at least 2. I'm choosing 3. Normally, I choose 5. But we'll stick with 3 for now. So you take the equation or the function, and everywhere you see an x, you substitute what you're evaluating it at in there for x. So -1/4 times -4. The 4's cancel. And a negative times a negative is a positive 1. And 1 minus 2 is -1. So that is the point -4, -1. Then I'm going to plug in 0. So -1/4 times 0 minus 2. -1/4 times 0 is 0. 0 minus 2 is -2. So that gives me the point 0, -2. Now I'm going to substitute in a third point. Again, a point that you choose. It's up to you which one you choose. You don't have to choose the same one that I did. Forgot to use different color there. So the fourths cancel, the fourth and the 4 cancel and leave -1 in this case, -2, and we get -3. So that's the point for -3. So you input at least 2 values and get the resulting output values, and then you will have at least 2 points, and you will plot those points and connect the dots to form a line. In this case, I did 3. So I did the points. I did -4, so -1, 2, 3, 4, down 1 for -1. So I'm going to put a point right there. And then I have the point 0, -2. So I'm going to put a point right there. And then I have the point 4, 1, 2, 3, 4, -3, 1, 2, 3. So I'm going to have a point right there. Now, it really helps if you have a straight edge. So if you have some form of a ruler, and if you don't have a ruler, that's okay. Like I am using the side of a small box, actually. That's what I'm using. Just using something as a straight edge, and oops, need to move my little box a little. There we go. So there's our line, and this is the line f of x is equal to -1/4 x minus 2. Okay, so that's how we graph using points. Make a table of values. You choose at least 2 input values, at least 2 x's. I chose 3. You're welcome to choose more. Substitute those values into the function. Get the resulting y values and put the x and the y together, or the input and the output together, to form a point. Then you'll have at least 2 points, possibly more. Plot those points. They should line up. Then connect them using your pencil and a straight edge. Okay, now that's not the only way to graph, and we're going to talk about other ways to graph in a moment. But first, let's talk about the graphical interpretation of a linear function. So f of x equals mx plus b. Remember that b is the y-intercept of the graph, and it indicates the point 0, b, at which the graph crosses the y-axis. So wherever it crosses the y-axis, that is the y-intercept. That, and we talked about y-intercept, is the starting value. The m is the slope of the line and indicates the vertical displacement rise and the horizontal displacement run between the successive pairs of points. So recalling the formula here. So with that said, you can use that as a shortcut to graph. So what you can do is you can figure out the m and the b. I always begin with b. These steps tell us to evaluate the function at an input value of 0 to find the y-intercept. So, but honestly, if you recognize y equals mx plus b, you can just pick that out without plugging in 0. And then identify the slope, and then plot the point that's represented by the y-intercept. So I always say begin with b. That's always my first point, is b, and then I use that to do a rise over run to determine at least 2 more points on the line, and then I sketch the line. So this is the same equation that we just did up here. So if you look, we just graphed y equals negative 1/4 x minus 2. We're going to graph the same exact line. And you might wonder why. Well, we're going to graph it, but we're going to use a different format. We're going to use this format here, where we plot the b and then use the slope to find a couple more points. So this is without doing a table of values. So what I usually do is I identify the slope. So my slope is negative 1/4. And I also identify my b, which in this case is negative 2. So this is the point 0, negative 2. This is where I begin. I begin with b. So on my, this is the y right here. This is the y-axis right there. And so I'm going to plot the point, the first point, 0, negative 2, on that axis. Okay. So then I need to do my slope. Second, you do slope, and slope is rise over run. So what you do is, starting at B, rise over run to find second and third points. So if I have the rise over run negative 1/4, I can do one of two things. This means I can rise down 1 and run right 4. Because here's the deal: if it's if something's negative, if the rise is negative, we're going to go down. If the rise is positive, we're going to go up. If the run is negative, we're going to go left. If the run is positive, we're going to go right. So when I have negative 1/4, that means I can go negative, let the negative apply to the 1, and so I'll rise down 1 and then I'll run right 4. Or I can do the opposite. I can rise up 1 and I can let the negative apply to the 4 instead. So positive 1 over negative 4. And in this way you'd run left 4. So I can either go up 1 and write 1, 2, 3, 4. So again, from B, I go up 1, rise 1. I'm sorry, I did this wrong. I apologize. And I lost my point. So let me put that back there. From there, we're doing negative 1, and I rose up. So I can either, from here, rise down 1, and then go right 3. So negative 1 on the rise, positive 4 on the run. Or, and I can do that again, down 1 and right 4. Or I can do the opposite. I can say negative 1 over 4 is the same as 1 over negative 4. So in that case, I could rise 1 and run left 4 for the negative. Either way, it lines up and forms a line. And this line is still y equals negative 1/4 x minus 2. It's the same line that we just graphed. It's just this way we found actual points. Here we're finding points as well, but we're not evaluating the function. We're just locating the b, and then from there using the slope rise over run to find your other points. So again, if it's a negative, if you apply the negative to the numerator, that's a negative rise, so you would go down 1 and then run right 4 for positive 4. Or if you let the negative apply to the 4 and the 1 would be positive, you rise up 1 and then let the negative make the 4 go negative. Now you are not limited to those 3 points. You can do the rise over run in either direction to find more points. So now, this one is interesting. This one, I don't want you to graph the line. The line is already graphed, but we want you to find a point on the graph we drew in this example that has a negative x value. So see if you can use the slope to find one more point that has a negative x value. Pause the video and then come back when you're ready. Okay, so I'm looking at the slope. My slope is from this point here to this point here. I'm going to go down 2, so that's negative 2. I'm going to go right 3, so negative 2. So the slope is negative 2/3. And then if I keep going down 2 and right 3, I'm not going to get any x values that are negative. But if I do the opposite, so instead of going down, instead of down 2, and right 3, we're going to do the opposite. We're going to go up 2 and left 3. So I'm going to go up from here. I'm going to go up 1, 2. There's not a point there. I'm going to go up 2 and go left 1, 2, 3 and put a point. Now it helps if there's actual graph paper there, but I'll just leave little tick marks where I counted. So up 2 and left 1, 2, 3. So this looks like that would be the point. So if this is negative 1, this would be negative 2. This would be negative 3, and we went up 1, so that'd be up 7. So the next point would be negative 3, 7. It would be easier to count if you had more graph paper and it wasn't cut off like it was there. So up 2 would take you to 7. Left 3 would take you to negative 3 for the x. So negative 3, 7 would be the example of a point with a negative value that is on this line here. All right, so before we go on, we're going to pause again and let you take a break and come back to the next video, part 4, for the next part of the lecture.